अच्छा, weak acids and their comparison. तो इसमें कि first thing, all organic acids are weak acids. So when I say strong or when I say weak, so I'm talking about a relative comparison. They're all actually weak. They don't like to produce H plus ions, and you have three weak acids. Four of them, water को तो वैसे ही बीच में डाला हुआ है. Three of them alcohols, phenols, and you've got your normal carboxylic acids. Carboxylic acids are like relatively strong acids. Phenols are relatively weak, and alcohols are the weakest. You can't even classify them as acids. ठीक है? So we did this you've got these reactions of alcohols and of ये alcohols, phenols, and you have carboxylic acids. You've got three substances. Alcohols are the weakest acids, so they undergo no acid reaction, no typical acid reaction. They don't react with strong bases. They don't react with weak bases as well. They don't react with carbonates. They don't react with NH3. Typical acids, they do react with them. खाली उनका एक ही reaction होता है, which is with sodium, and even that is very, very slow. It's a very slow reaction. ये बल्कि यहाँ पे, I should add that even with sodium usually reacts very vigorously, but even with sodium, you've got an extremely slow reaction. बस थोड़े थोड़े bubbles बनेंगे, very slow reaction. ठीक है, that's with sodium. Phenols, they're slightly more acidic. So phenols will react with sodium. They will also react with sodium hydroxide. What phenols will do is the H will be lost. They're going to lose the H plus one like an acid. Na will take its place and it will form a salt. Or NaOH ke saath, it's going to be the same thing. Na is going to take its place and you're going to form water in this case. तो NaOH के साथ जो reaction होता है उसके अंदर salt plus water produce होता है. Na के साथ जो reaction होता है it produces salt plus hydrogen gas. Or the name of this thing is also important. This thing is called, this particular thing is called, it's a phenoxide ion. So this is known as a sodium. So this one is known as a sodium phenoxide. ठीक है? वो नीचे वाला भी, that's the same thing. It's sodium and phenoxide. अच्छा, sodium phenoxide. Phenol to phenoxide. ठीक है? That's the ion. Now phenols are not as strong an acid, so they don't react with weak bases like carbonates, and with ammonia they don't react. Then you have finally carboxylic acids. Carboxylic acids are your typical acids. They undergo all react. They're the strongest acids, relatively speaking. They will react with sodium metal to form salt plus H2. They will react with NaOH to form salt plus water. They will react with a weak base, which is a carbonate, and they will form salt, water, and carbon dioxide. Or ammonia के साथ they will react and they will form an ammonium salt as well. ठीक है? So these are your strongest acid. और फिर हमने पढ़ा था कि we started talking about explaining acid strength. And the first part was that alcohols are the weakest of the weak acids. They ionize even less than water, and even water produces 1 into 10 to minus 7 mole per dm cube, very few H plus 1 ions. So alcohols, they are going to produce even less H plus 1, almost non-existent H plus 1 ions. That's a very small number. So alcohols basically don't like to produce H plus 1 ions. तो उसका हमने पढ़ा था why is that? So the reason why alcohols happen to be the reason why alcohols happen to be the weakest acid is the reason why alcohols happen to be the weakest of all the weak acids is they got an alkyl chain, they've got a carbon chain. तो हमने discuss किया था, they've got a carbon chain, and any carbon chain, any alkyl chain, it has an electron donating effect. It pushes electron density on any group that is attached to it. So if you have an oxygen over here, if the alcohol splits up and the H plus 1 leaves, you've got electrons over here, and there's more electrons being pushed onto it. So what will happen is that there's going to be a lot of electrons accumulating over here. Okay, so H plus 1 has left its electrons there. It has left. Uh, it has dissociated. And there's more electrons coming from the carbon chain that are being pushed onto this O minus 1. So what happens is that the negative charge becomes very, very large. And if the negative charge becomes very, very large, what will happen is that it will attract the H plus 1 back again. It will not let the H plus 1 go. So जो OH bond होगा ना, that's going to be very strong. It would be very hard to actually break the OH bond. So because of the electron donating effect, the negative charge density over here becomes large. इसके लिए जो correct word होना चाहिए, that should be negative charge and density. So the negative charge density is going to be very large. So the H plus 1 will not be able to leave. It will be very strongly attracted to this and it will not dissociate. So uska jo answer aapne likhna na, that's this one, that alkyl chains, they've got an electron donating effect, which increases the charge density on this ion. And there's strong, ye humne bilkul end mein kiya tha, let me just rewrite this. तो बाकी सब कुछ तो ठीक है, एक वर्ड मैंने बीच में ऐड करना है कि लास्ट टाइम मैंने बड़ी जल्दी में किया था. अच्छा, so it increases charge density on the ion, making it, they use a word that is making it unstable. So whenever the charge density increases, the ion will become very unstable because it's going to attract something. So making it unstable, and which leads to stronger. So there's stronger attraction for H plus 1 ions. So that would lead to less dissociation. The H plus 1 will not be able to leave. Or you can also state that the OH bond becomes, the OH bond strength increases, so less dissociation because of that. The OH bond strength, it increases. So उसकी वजह से there's going to be less dissociation. अच्छा, ये clear है? Is this part clear, that why alcohols are such weak acids? Is this part clear?
Yes, sir.
ठीक है, सना clear? Haseeb, Abi, is this clear? This is one clear है? Okay, वो next part पे जा रहे. That's the next part. Next part is we're going to move towards as the next part is we're going to move towards the other one, which is the second one, phenols, right? So phenols are slightly stronger acids compared to alcohols. So why is that? So phenols are, and you have to explain that. So are slightly stronger acids compared to alcohols. Okay, so the next question is, what's going on with phenols? Why are they stronger acids? They react with, they can react with, so they can react with sodium metal and NaOH. So they can react with reactive metals as well as strong bases. and also with strong. So also with strong bases. So here's what phenol, what's going to happen with phenol. Okay, you've got, so here's your typical benzene, and it's going to have an OH group that's attached to it. Okay, ये बन गया benzene, and it's got this OH group that is attached. That is attached to it. Okay, that's a phenol. Same thing, what will happen is that the phenol will ionize, but the dissociation is going to be stronger compared to alcohol. It's going to ionize more. ठीक है, तो वो ज्यादा आयनाइज होगा, तो ये जो H है ना, that leaves and leaving behind oxygen with its electrons. ठीक है, let me put it this way, that so leaving behind its electrons, and it's a reversible process, so both forward and backward reaction can actually happen or take place, and ठीक है, that's the reversible sign. Actually, now the question is, why does phenol ionize more? Because the negative ion over here does not attract the H plus one that strongly, which means that it has a relatively weaker conjugate base. It's got a relatively weaker conjugate.
सर
हाँ
सर तो जो ऑक्सीजन पे जो नेगेटिव चार्ज होगा वो मतलब कम होगा?
हाँ, वो कम होगा कि वो इस पर्सन को अट्रैक्ट नहीं करे, और उसकी रीजन क्या है, व्हाई वुड इट बी लेस? ठीक है, द रीजन इज कि भाई, वेयर डिड द नेगेटिव चार्ज गो? इट्स गोइंग टू मिक्स अप विद द बेंजीन इलेक्ट्रॉन क्लाउड. ठीक है, द इलेक्ट्रॉन क्लाउड, it's going to start overlapping with the benzene's electron cloud. तो वो 246 वाला concept नहीं था, the same thing will happen, but this time we're not interested in the benzene. What's happening is कि उसका lone pair जो है ना, उसका जो negative charge है, that has gone and it has mixed up with the electron cloud over here. So if it does that, so the negative charge over here is going to be lesser. So there's going to be lesser charge density. So because of that, because of the lesser charge density, the H plus one will be less attracted to it. तो ये जो आपका H plus one है,
सर
हाँ जी,
सर ये ऐड अप हुआ है तो ग्रेटर चार्ज डेंसिटी नहीं होगी?
नहीं फैल गया ना, ऐड नहीं हुआ, एक्चुअली वो उधर जाके डिस्ट्रीब्यूट हो गया उसके साथ. यहाँ पे चार्ज डेंसिटी ज्यादा हो गई है, पहले कम थी, यहाँ पे ज्यादा हो गई, यहाँ पे एक्चुअली कम हो गई.
ओके सर.
वो खुद सोचो ना कि लेट्स से एक वायर है, तुम एक साइड पे नेगेटिव चार्ज रखते हो, क्या होता है, वो नेगेटिव चार्ज फैल जाता है ना, क्योंकि नेगेटिव चार्ज तो इकट्ठा रहना नहीं चाहता, वो तो इट वांट्स टू गेट डिस्ट्रीब्यूटेड. नेगेटिव चार्ज इलेक्ट्रॉन्स रिपेल अदर इलेक्ट्रॉन्स, राइट? तो अगर एटम के एक साइड पे ना देयर इज अ लॉट ऑफ इलेक्ट्रॉन्स, दोस इलेक्ट्रॉन्स विल सॉर्ट ऑफ गेट डिस्ट्रीब्यूटेड ऑन द एंटायर एटम. आइडिया क्लियर है?
यस सर.
तो ओवर हियर देयर इज गोइंग टू बी लेस.
यानी ऑक्सीजन के ऊपर से नेगेटिव चार्ज हट जाए.
हाँ, मतलब वो नेगेटिव चार्ज बेसिकली अब है तो उतना ही नेगेटिव चार्ज, लेकिन अब वो उधर से हट गया, इट्स गॉट डिस्ट्रीब्यूटेड. ठीक है, तो चार्ज डेंसिटी कम हो जाएगी, द इंटेंसिटी ऑफ द चार्ज इज गोइंग टू बी लेसर. ठीक है, क्लियर है?
यस सर.
तो ये वो रीजन है, दैट्स व्हाई so basically OH bond strength has decreased, there's less attraction now, so that means it's going to be easier to ionize. ठीक है, इसको you just have to explain that in words कि why are phenols relatively stronger acids. So all you have to write in this case is कि first thing कि lone pairs के बारे में. ठीक है, so lone pairs on the phenoxide, Yeah, it's kind of, you can write the formula of this. This is C6H5. Benzene is C6H5, and there's an O minus one that's next to it. Okay. So the lone pairs on the phenoxide ion overlap with benzene's pi electron cloud. So they overlap with benzenes. Pi electron cloud. And when that happens, when they overlap with benzene's pi electron cloud, when that happens, so charge density on the phenoxide ion decreases. Decreases, and when it decreases, it makes the phenoxide ion more stable, making it making it more stable. Basically, less attraction for H+1 ions. या फिर आप इसको ये भी लिख सकते हो, the OH bond weakens. So hence there is more dissociation in this case now. So hence there's going to be more dissociation. फिर you've got other things as well कि there's going to be a variation as well, ठीक है, in this. लेकिन ये part clear है कि why this is stronger than alcohols, why it's easier for it to lose H+1 compared to an alcohol. Is that clear?
Yes, sir.
अच्छा अब ये कि so it's easier for it to lose H+1 compared to alcohols. Now the next thing is कि so ठीक है, this is easier. Now there's going to be some variations in this, ठीक है. They'll ask you a lot of stuff about phenols, which are more than phenols, ठीक है. I mean, the basic structure is a phenol, but maybe they might have a carbon chain. So let's say, so within phenols भी ना comparison होंगे, ठीक है. So they might give you a phenol which is phenol, and there's another one which has a carbon chain attached to it as well. So your neighboring, this is, you got CH3, you got CH2, and you've got another CH2. So you got this big carbon chain that's attached to it, ठीक है. Now इसको versus कर लेते हैं. अच्छा, so this is like comparison of acid strength within phenols. So acid strength. Let's know this one. So which one is going to be a stronger acid? They're both going to ionize, ठीक है. तो इन दोनों को ना ionize कर देते हैं, ठीक है. Let's make them lose H+1, and then we'll see के who is the one who's more likely to lose an H+1. तो यहाँ पे it lost an H+1. This one also lost an H+1, ठीक है. Let's say the H+1 is close by at the moment, ठीक है. The negative. And you've got this one as well. As anyway, so you've got two phenols, both of them. अच्छा, both of them ionizing. And we need to find out who's stronger. अच्छा, so अब यहाँ पे ना the phenol explanation will not work because both of them are phenols, ठीक है? So the difference is not because they're actually phenols, ठीक है? तो वो जो explanation that we just did, that will not be causing the difference because they're both phenols. The reason is going to be that over here you've got a carbon chain and an alkyl chain has what effect? It's got an electron. It's got an electron donating effect. Now, if it's got an electron donating effect, this one over here, the overall effect will be कि यहाँ पे क्या effect आएगा कि if on one side there's a group that's pushing electrons to the right, what will happen to the charge density over here? ज़्यादा होगी, कम होगी?
सर कम होगी
नहीं, ये electrons push कर रहा है ना,
और ज्यादा होगी सॉरी.
तो the negative charge density over here increases. That's it's going to be higher. So that will make it unstable.
सब वो जो इलेक्ट्रॉन डोनेटिंग इफेक्ट के इलेक्ट्रॉन्स है उससे वो ऑक्सीजन की तरफ आते हैं ना फिर.
मतलब ओवरऑल इफेक्ट तो यही होगा ना, पहले तो हमने वो डिटेल में थोड़ा पढ़ा था, बट द ओवरऑल इफेक्ट वुड बी दैट somebody is pushing electrons from one side, ठीक है? So overall there's going to be a net increase in electron density on the right side. Is that clear?
यस सर.
So there's a negative charge density is higher, and since अच्छा एक सेकंड रुकता हूं, मैं ये एक सेकंड टाइप की एक चीज कर लूं. अच्छा ये so what will happen is that the negative charge density is higher. It's going to make it unstable. Or you can say okay, there's going to be a stronger OH bond, ठीक है? OH और OA and H के बीच में the attraction is going to be stronger. So you're going to have a stronger OH bond. हाँ जी.
सर तो लेफ्ट वाला मतलब स्ट्रॉन्ग एसिड होगा ना, एसिड
हाँ,
स्ट्रेंथ
ये
उसकी
ये
ज्यादा होगी.
ये weak acid होगा. This one will ionize less dissociation. So this one is going to be weaker. ठीक है? And so that one is the one that's going to be a stronger acid. This one is going to be a weaker acid. Is that clear?
यस सर.
तो इस तरह के comparisons बहुत आएंगे, and vice versa you can also get an electron withdrawing group like NO2 attached to it. So what will happen in that case? Let's say वो कर लेते हैं instead of, I mean the opposite will happen, ठीक है? So you just have to write the same thing but the opposite of that, ठीक है? So let's say you've got one is a phenol, the other one is a nitrophenol. मतलब यहाँ पे ना there's an NO2 group attached. वो हमने जब शुरू में लिस्ट की थी ना, the NO2 group is an electron withdrawing group, ठीक है? So this group is an electron withdrawing group. तो
सर तो इस केस में ये स्ट्रॉन्ग होगा ना.
हाँ, तो इस केस में होगा कि वो जो इसके लोन पे है ना, मतलब H+1, right? So in this case, what will happen is electron withdrawing group, so the negative charge density over here will be lesser. ठीक है, that is lesser. That will make it more stable. Stable over here means less likely to change. Because if it becomes lesser, it no longer attracts H+1, less attraction for H+1 ions. Or we can say that the OH bond becomes weaker. ठीक है, clear है? So we did study electron withdrawing group, electron donating groups. ठीक है, we've already studied that. तो वो पूरी लिस्ट हमने लिखी थी लास्ट टाइम, ठीक है, ऑन द अदर बोर्ड. So just make sure कि remember this. Phenols clear है?
Yes, sir.
ठीक है. अब as a rule of thumb, just remember focus on the negative charge over here. Okay, negative charge if it's higher, तो it's going to be a weaker acid. If it's lesser, it's going to be a stronger acid. हर दफा you
सर
हाँ
सर लाइक वैसे सिर्फ शॉर्ट नोटिस का सर, वैसे मतलब जो रीसेंट सिलेबस है जो अपकमिंग एग्जाम के लिए सर,
हाँ
उसके अंदर कोई चेंजेस आए कंपेयर टू प्रीवियस इयर्स?
जो ऑर्गेनिक है,
हाँ सर, ऑर्गेनिक का सेक्शन.
असल में जो चेंजेस आई है ना वो आई है कि एएस की चीजें ए2 में डाल दी, ए2 की चीजें थोड़ी सी एएस में डाल दी है. लेकिन सिंस यू आर डूइंग ए2 तो बेसिकली आपके लिए तो सब कुछ सेम है. हाँ
ओके सर.
नहीं, उससे पहले चेंजेस काफी आई थी, 2019 में बहुत आई थी. 2022 के अंदर नहीं कोई ज्यादा स्पेसिफिक चेंजेस इसमें नहीं है एक्सेप्ट फॉर, नहीं बस उसमें ये वाला जो सेक्शन है ना उसमें कोई खास चेंजेस नहीं है, बस वो है कि रीअरेंज हुआ है थोड़ा सा. दैट्स अबाउट इट. वो वैसे हम सिलेबस साथ खोल लेंगे, ठीक है. थोड़ी सी चीजें आई थिंक एनालिटिकल के अंदर ना वो कम हुई है थोड़ी सी. अच्छा अगला पार्ट कौन सा रह गया? कार्बोक्सिलिक एसिड, ठीक है. सो द लास्ट वन. So the last one is why are carboxylic acids relatively speaking the strongest acid, ठीक है. अच्छा so why are carboxylic acids important चीज है relatively the strongest acid. अच्छा ये काम हमने सारा we have to do this for bases as well. तो और इसके अंदर there's going to be variation as well, ठीक है. So you've got अच्छा we've got a typical carboxylic acid. Same logic, same reasoning, ठीक है कि भाई negative charge if it's higher then it's going to be a weak acid. If it's lesser it's going to be a strong acid. So this is your typical carboxylic acid, CH3CH2. और फिर there's a C double bond O and OH. अच्छा so relatively speaking this is your strong acid. So when it ionizes, same thing happens. You've got an OH group. अच्छा इन सारों में OH groups ही होते हैं, ठीक है, which is ionizing. So you've got the same carboxylic acid, the OH. So the OH over here it loses the H plus one, and you've got negative charge accumulated on this oxygen over here, and it's a reversible reaction. So you got this thing going. Now the reason a carboxylic acid is relatively ठीक है, बोर्ड लिंक तो मैं भी शेयर कर देता हूँ, एक सेकेंड. अच्छा ये मैं वरना मैं भूल जाऊंगा, ठीक है, एक सेकेंड. ये where's just 1 second. So remember ये this is second, ये part 2 है उसका, ठीक है. फर्स्ट पार्ट में we did electrophilic substitution. So this one I've shared it over there. Achha, now this one is so why are carboxylic acid relatively the strongest acid? So it all lies with this oxygen over here, it's got a very, very strong electron withdrawing effect. Why? Because oxygen is obviously electronegative. ठीक है, oxygen is one of the most electronegative elements out there. ठीक है, so it's तो यहाँ पे ना electron withdrawing effect that's very, very strong. So carboxylic acid की जो शक्ल होती है ना, it actually turns into something like this. That that you got a CH3, you got a CH2, and then you've got a C.
सर
It's got a double bond OG.
सर आपने यहाँ पे जो एरो बनाए सर ये क्या इंडिकेट कर रहे हैं?
वो जो नेबरिंग ऑक्सीजन नहीं है वो इलेक्ट्रॉन्स विड्रॉ कर रहा है ना,
ओके सर
कि यहाँ पे नेगेटिव चार्ज था ना, OH था ना, OH left leaving the electrons. So there was negative charge over here. The negative charge got distributed. Oxygen tried pulling the electrons. एक और oxygen था ना, which is very electronegative. This one,
यस
ये वाला, ठीक है.
यस सर
So it's got a very high electronegativity. 3.5 होती है मेरे ख्याल से, which is, yeah, I think it's more than 3.5. Cl 3.5 होता है. This is probably more than 3.5. So it's very, very electronegative. अच्छा, होता ये कि the negative charge over here, it eventually what happens is that the whole negative charge, and there's a pi electron cloud as well. What eventually happens is that the whole negative charge actually kind of gets distributed between the two atoms. So it kind of gets distributed, and the whole negative charge is actually now very, very distributed on the entire thing. So idea clear है कि it's the H left its electrons. The electrons were accumulated over here, but the two oxygens ended up fighting over all the electrons. There was a pi electron cloud. There were excess electrons over here. Eventually, there was this whole electron cloud that got mixed up. Iske electrons, they all kind of got mixed up between the two oxygen atoms. So the whole negative charge is now over the whole thing. Is this clear?
सर तो बेसिकली वो लाइक इलेक्ट्रॉन क्लाउड बन गया ना बीच में उनके, वो आपस में शेयर कर रहे थे इलेक्ट्रॉन्स.
हाँ, लेकिन वो चार्ज डेंसिटी कम हो गई है ना. पहले तो वो कॉन्सेंट्रेट था ना, नेगेटिव चार्ज वाज ऑल ओवर हियर.
यस
अब वो फैला हुआ है, ठीक है. सो द चार्ज डेंसिटी इज नाउ अ लॉट लेस है, ठीक है. तो बस ये इसकी explanation is, which is why, so the electron withdrawing effect is very, very strong. So the answer for this is कि in carboxylic acids, a highly electronegative oxygen in the C double bond O group so a highly electronegative oxygen in C double bond O has strong electron withdrawing effect. And since it has strong electron withdrawing effect, what it will do is it will decrease. So which decreases negative charge density on the ion. On this RC double O minus one ion, ठीक है, C double bond O minus one ion. So there's going to be less attraction for H plus one. Yeah, पहले तो लिख दो making it stable. So there's less attraction for H plus one ions. Or what you can say is the OH bond strength increases. So the OH bond strength increases, or so hence it's going to be a very weak, relatively strong acid.
सर OH bond strength डिक्रीज नहीं होना चाहिए था?
डिक्रीज हो रहा है, हाँ डिक्रीज हो रहा है, नहीं इंक्रीज नहीं। अच्छा अब 20% जा रहा है, ठीक है, वो डिक्रीज हो रहा है, ठीक है, 8 डिक्रीजेस, सही है, अट्रैक्शन डिक्रीजेस, ठीक है। So there's going to be more dissociation and it's going to be relatively a stronger acid. So it even reacts with weak bases like carbonates and ammonia as well. So it's going to be relatively a strong acid. So ये इसका, so why are carboxylic acids relatively the strongest acids? That is the reason for this. अच्छा वो खैर वो ये क्लियर है सारों को, इसमें कोई इशू नहीं है, इज दिस क्लियर?
यस सर।
यस सर।
अच्छा बाकी फिर वो कल ही होगा क्योंकि वो एक नई स्टोरी है इसकी।
सर
हाँ, विद इन कार्बोक्सिलिक
सर
एसिड, जी जी।
सर इसके अंदर जो है सर, इसके रिलेटेड सर आप क्वेश्चन प्लीज दिखा सकते हैं, जैसे कि लाइक हमें एरोज ड्रॉ करने होते हैं या रीजनिंग होती है उसके अंदर?
रीजनिंग नहीं होती है, एक सेकेंड, अच्छा एसिड, एक सेकेंड, एक और था, इसमें कार्बोक्सिलिक एसिड नजर आ रहा है। अच्छा यहाँ पे ना the polymer ठीक है, just second, ये which of the, अच्छा सही, chiral, ये सेकेंड, इसमें तो टेस्ट की आ रहे हैं, हाँ ये वाला है ना जिसका describe and explain how the acidities of this thing will compare with this one and to the acidity of ethanoic acid. ये भी हमने within ethanoic acid या carboxylic acid ना, we have to do comparisons. We studied कि carboxylic acid are the strongest acid within carboxylic acid. अब next class में पढ़ेंगे, ठीक है।
ओके सर।
प्लस उसमें ना रिएक्शंस बहुत आएंगे, वो क्वेश्चंस भी पूछेंगे कि भाई वो अगर तो कोई टेबल गिवन है ना कहीं गिवन होगा, इस तरह करके ना दे माइट ऐड Na, तो आपको बताना होगा Na के साथ कौन रिएक्ट करता है, और सोडियम कार्बोनेट, who's going to react with sodium carbonate. So there are going to be questions related to, उस तरह के questions भी होंगे, एक सेकेंड, पता नहीं इस वाली स्पेसिफिक वर्कशीट में है। तो उस तरह के क्वेश्चंस भी हैं। ये वो हाइड्रोलिसिस, ये लास्ट टाइम ने हाइड्रोलिसिस पढ़ा था ना, उसमें वो कहा था कि who's going to hydrolyze fast, who's going to, ये तो लास्ट टाइम वाला क्वेश्चन है। हाँ ये वाला जिससे ये नहीं है, नहीं
यस सर।
खैर ये फिनोल एंड NaOH, चलो ये तो पता होगा ना कि फिनोल रिएक्ट्स विद NaOH। तो if they give
यस सर।
if they give you phenol with sodium carbonate, there's not going to be any reaction, ठीक है। चलिए ठीक है। अच्छा P5 की तो वो कर लेते हैं क्लासेस बीच में ना, वो अलग से, बल्कि ऑर्गेनिक हो जाना, विल डू P5, ठीक है, बीच में हमने थोड़ा सा किया था, विल आल्सो डू P5, ठीक है। उसकी तैयारी इतना इतना वो इतना मुश्किल काम नहीं है, वो आसान ही है, उसके पास पेपर क्वेश्चंस प्रैक्टिस करेंगे। चलो ठीक है, ये इसको कंप्लीट करेंगे, एसिड स्ट्रेंथ वाला कंपैरिजन, ठीक है।
ओके सर।
चले, ओके, हाफिज।